morning. Thank you for being here still at this time, and it's a pleasure to introduce this topic, and thanks for having invited me today. I will go through a little bit in the new languages. I have to say that was the concept of today. And I did ask, as even Carlo did this morning, to ChatGPT what was the link between gonadotropin and oocyte competence. So this was a mind map that came out, and of course, so forget about it, and I will take you through a different way instead of seeing the relationship between gonadotropin and oocyte competence. So let's go first of all to see, we have heard during these days, and I'm sure you know much better than me, what it's the meaning of an oocyte to be competent. That of course refers to its capacity to undergo complete maturation, then that will lead to a successful fertilization. It should be able then to support pre-implantation development through the blastocyst stage that then ultimately results in implantation and a viable pregnancy. So in this, what do we have to consider? The maturation of the oocyte from a cytoplasmic point of view and even from a nuclear point of view. We've heard a lot about the morphologies that we have, so this is an example of what these oocytes might look like. And the other player of these days for us are gonadotropins. Again, which are their role in reaching the competence stage. So we heard a lot, and so we'll go quick in this on the role of FSH and LH that are all the one that we know well known. So first of all, anyway, we need to point out that there is a crosstalk. It's not just the oocyte itself that would reach the competence, but it needs the help of even the granulosa and T cells that surround it. So there will be an interaction between them and the gonadotropins. In particular, these cells are able to respond directly to FSH and LH, so will produce factors that will then be brought to the oocyte. These factors I will show you, and even Livio Casarini yesterday showed us that activates molecules within the oocyte in order to reach this competence. There are other factors here, there are several listed, and if we have an impairment in these mechanisms, then the oocyte will not be fully competent. What on the other side we know from instead in vitro maturation, because often we are obliged to rely on oocytes that have not complete their maturation in vivo, so they will be retrieved before the LH surge, and we're going to perform, the maturation in vitro. That might not reflect exactly what happens in vivo, and so we might have some inappropriate communication between these two cells. So we are always in the search of a refinement of these outcomes. So this is a little bit what we all know, and so how do we improve our knowledge? Because when we are thinking to the oocyte competence, we are now more related to an oocyte that has started maturation. But within the ovary, we have to take into consideration that there are other type of follicles that are still in a quiescent state, such as the primordial follicles, some that have started the activation process, so they have undergone a recruitment, that are the primary follicles. So what happens, and the competence of an oocyte has to rely even on these type of follicles, not just the one that will be in the preantral, antral stage, and so on. And So this is a way of thinking that, and I will take you more through these type of follicles from now on, instead of the one that you have seen during these days. And in particular, we have to go back to what we heard at the beginning of this conference by Livio, where he showed us that, and now we all are fully aware that LH may have also an anti-apoptotic effect. So it's able to promote a survival in the granulosa cells, activating pathways, again, the PI3 kinase AKT and ERK pathway, promoting the survival or survival signals inside our follicles. And related on these information that we had from Livio, we decided to go back again in the dynamics of our follicles, and we concentrated our attention on the primordial primary follicles. So those follicles that have to stay within the ovary for quite a long time in order then to be recruited throughout life. So what do we know? We know that there are activating signalings, molecular pathways that control their activation, as well as signals that will activate the loss of these follicles through atresia and specific other mechanism. So how did we work to then study these primordial follicles? We used a mouse model because it gives us a lot more possibility to work just on a strict population of primordial follicles. So we worked on pups, where the ovary mainly has primordial follicles. So it was just one stage. We induced damage, so we promote the loss of these follicles in order to see if LH was able to make them surviving. And so the way we worked was to induce damage by chemotherapy. You can see it up here, and then the rescue of the primordial follicle, because was our goal for the rescue, giving LH, administration of LH, together on directly PAPs and different chemotherapies, and even when we had an administration at older mice. We did then wonder what was, of course, the mechanism, because by having these results, we still did not know the way LH could activate these surviving factors. So we did observe modulation in several proteins within prepubertal ovaries. So again, there is a situation when normally we think that LH is not functioning. There is a list here of all molecules. Of course, we were concentrating on, at that time, on anti-apoptotic factor that did increase in the presence of LH. And we then shift these information from a mouse model to female or human ovaries. The situation here is a little bit more complicated, as you know, because it's difficult to get just an ovary with primordial follicles. So the possibility is to get cortex, human cortex, in which we have a high amount of these follicles. And again, we do see survival, so a death with chemotherapy, and survival instead when we culture these cells, with this tissue with LH. But so given that this concept is becoming more and more consolidating from us in other systems, even going back in embryo, fetal life, on primordial germ cells, and other groups are again incrementing this knowledge, we discussed with Antonio Lamarca something that he did presented yesterday about the possibility of instead working on the primordial follicles in the way to have more activated follicles. And so the idea that we've been working together also with Antonio was, how does this LH, this administration of LH, can act on these very small follicles, primordial and primary follicles. We are working on the basic level, so we are trying to understand which is the mechanism by which this LH can function. And so I will not go into the details, don't worry. I will remain on a general level, but just to show you that within the oocyte, again, we have several pathways that has to be activated in order to have the recruitment of these follicles. These are studies that had the aim to see how can physiological administration, let's say, physiological meaning without the damage, because in the first experiments we were creating a damage, a stress, and then that was the response of LH. Now we've moved to instead a physiological role of LH in activating or promoting the survival of the ovarian reserve. And in order to do this, we went back to check the expression of the receptor of LH in these pups, either in mouse and human ovaries, and these are the information about the expression of the receptor in ovaries, even very young ovaries, as you can see here for mice, and the expression on ovarian tissue that we do get the receptor that is present. So knowing that is present, we can start thinking to directly inject. This is the protocol that we have been using, injecting pups, as I was saying, the population of which we have just primordial follicles, and instead mimicking a little bit more the condition that Professor Lamarca is doing. So young adult pups receiving LH. Several injections for 8 days, and then a collection of ovaries and the serum to have them analyzed and see what is going on. This is to show you how the ovary changes in pups. We have an increase in the volume. First of all, sizes of the ovaries are bigger here. And then we do all our histological, being in a histology lab, so we do all the histological counting, because it's also the only way at the moment that we have to count follicles. And again, I will just focus on the two populations that we are interested in. Primordial follicles with LH did show an increase, or anyway a maintenance compared to control, and even if not significant, we do see a trend of reduction of atretic follicles. Similar results, we are getting them when we inject the young adult. Again, an increase in the size of the ovaries here. In this case, they stay stable because they have reached the correct size, and then instead with LH we do see an increase in the volume. That means, what is the meaning of this increase in volume? Where is the volume that we are seeing increasing? It is, again, just two populations that I want to show you, is the primordial follicle. Again, a little bit, not significant at this stage, but where we do see a significance will be in the decrease in the number of atretic follicles in the presence of LH. Plus, now what we are seeing is a high increase of instead the corpus luteum, so meaning that there is an ovulation going on in these, or a higher ovulation going on in these mice. And so we did analyze the estrous cycle. If these were the results that I just showed you, these are the how the estrol cycle goes in mice, but then we were wondering, okay, is ovulating, are we actually getting correct oocytes? And these are the number of oocytes that can we retrieve after the administration, so for this long time of LH, so for sure an increase compared to the control. And having said all this, okay, we do have an action on LH, but again, we still not exactly know the mechanism by which LH is functioning. And so we decided to go back in literature and have an idea of the situation of our pups, what is really going on, and we have gone through the mini puberty, this concept in which we know that this is the graph for girls of what happens during gestation, and then straight after postnatal life, we do have an increase of LH, that will be this one, an increase in FSH, and even an increase of estradiol, just in the first month of life. This is more known, its action in male, where it is known that promotes testicular growth, even relation with brain development. Much less known instead is in girls. In girls anyway, is thought that it will promotes, in some way interacts with growth of ovarian follicles. It will again have effect on brain. For sure, the same situation here I've reported is what we see in mice. So again, our model on which we work is a good model to understand things going on in humans, that it's a bit more complicated. And it is said so that it plays a role in germ cell development, sexual differentiation, and again, brain development. So if we are injecting, so we are studying our primordial population, is this primordial follicles, are these primordial follicles be influenced by LH or FSH, in particular, it seems a little bit more FSH. And what this is are really ongoing experiments, so I hope by the end of the year to have the complete results. And I'm showing you that we do have a modulation of hormones, especially, so the level of LH are kind of stable, while we do see an increase, an increment more than what we normally see in the control of FSH. Similarly, the results, these are for the young adult. Again, LH, it's stable, no matter if we give LH, there's no extra addition. And, whoops, sorry. FSH again is increasing, so indicating that there is a relation with this mini puberty. And really last results that we had these days is that when we inject, sorry, this is the protocol again, we inject CD mice, young mice with LH, and then we started the mating, so we actually decided to see what if we had any improve in the pregnancies, and you can see that we get a lot more pups when we treat mice with LH when they're young. So we are actually activating something at this level. Again, we do not know exactly the mechanism. I hope that we'll have these results soon. So for conclusion, we can say that LH is limiting atresia at the primary stage of folliculogenesis, accelerate spontaneous folliculogenesis since we see the corpus luteum, and promotes pregnancy rate and increase in litter size. With this, I would thank you all, and thanks all to the collaborators, and because I'm absolutely sure that science moves forward through collaboration. So thank you